Welcome to the screencast. I'm going to do the screencast for 2.2, linear relations and functions. So in Algebra 1, we discovered a function is linear if the independent variable increases or decreases at a constant rate. So here the independent variable is x, so we're looking how x is going to be changing. So if the independent variable x increases or decreases at a constant rate. Okay, so if we see a line, it's going to be linear. So if you see a line, that's linear. Line, linear. So x is the independent variable and it's graphed on the horizontal axis. Normally that's going to be time. And y is the dependent variable. So that's going to be the output of the function. So it totally depends on the x value. So the x-intercept is where a line crosses the x-axis. So notice the x-intercept, you have 0 for y, but you have an x value. X-axis, x-intercept, x value. Versus y-intercept, it's where you cross the y-axis and you'll have a y value. So we'll find out how to do that later. So the rest of this chapter we're going to spend working on this. So we're going to be covering slope of a line in 4.3. Point slope form is 4.4 or 5. 4.5. Slope intercept form 4.4. Standard form is 4.2. So this lesson. Otherwise, this is the core. That's the meat. So linear relations are graphs or straight lines. They have no operations or variables other than addition, subtraction, multiplication. Linear equations cannot have powers of variables other than 1. Powers of variables other than 1. So check this out. This y squared, that's higher than 1. That's not linear. They cannot have square roots of variables. So look, this is a variable square root. However, we can have a square root of a number. For instance, if I have y equals square root of 3 times x, that's fine, because you have the square root of the number. You can't have a square root of a variable. You cannot have, you cannot have variables in the denominator. That's ugly. So check this out. This x is in the denominator. You cannot have that. And then you also cannot have a product of variables. So what does that mean? Check out that xy. That's a product of variables. That's a product of variables. X times y. So state whether each is a function, if it's linear or not. So this guy is, because you just have x by itself, he's fine. This one is, you're fine. Because notice, like, we don't have any exponents that's greater than 1 in either one, a or b. We don't have any square roots. We don't have product of variables, like an x times a y. And we don't have x in the denominator. Speaking of denominator, check that out. That is not linear, because x is in the denominator. And this guy is not linear because we have a product, we have an exponent that's greater than 1 because we have that y squared. So example 2, the growth rate of an example of Bermuda grass is given by the function f of x equals 5.9x plus 3.25, where f of x is the total height in inches. So f of x is the height in inches, and x days after x is days after initial measurement. What are the independent and dependent variables? So the dependent is going to be your f of x, your y value. This is going to be your height. Because how high are you? Well, what's the height of the grass? It totally depends on your day that you're going to be measuring. So the independent variable is going to be x. It's your time. Here it's length in days. How tall is the sample after 3 days? So we'll plug that in. F of 3 is equal to 5.9 times 3 plus 3.25. So it's going to be 17.7 plus 3.25, 19.95 inches tall. So the term 3.25 in the function represents the height of the grass, which was initially measured. How many times taller is it after 3 days? So you take, 19.95. Oops, this should be 20.95. Alright. Oh no. 17.7 plus 3.25 is 20.95. So you take 20.95, divide by 3.25, and we get how much taller it is. So that's 6.44 times taller. So standard form is a linear equation. So that's written as ax plus by equals c. A, b, and c are integers with the greatest common factor of 1, meaning there's no common term you can pull out. Also, a is greater than 0, and a and b are both not equal to 0. So let's try this out. So I need to have a greater than 0, so I'm going to move the 5 to the left side and subtract the 2y. Another way to write this is I could say 4x minus 2y is equal to negative 5. So a is greater than 0, so that's good. So a is equal to 4. B is equal to negative 2. Check it out. A and b are not equal to 0. And then c is going to equal negative 5. So we made sure a and b are integers. A is positive, and c, that's fine. It could be 0, it could be negative 5, it's whatever. So the first thing I notice here is I have a common factor of 3. I can divide everything by 3. So notice that the greatest common factor has to be 1. So x minus 2y minus 3 is equal to 0. Move 3 to the other side, right, by adding it. So x minus 2y equals 3. Sweet, I have it in the right order. So a is equal to 1. Nice, it's positive and it's an integer. B is negative 2. So a and b have to be both not be 0. And then c is equal to 3. Alright, so the intercepts are the x and y coordinates at a point at which a graph crosses the axes. So remember, the x-intercept crosses the x-axis, you'll have an x value. So here is the x-intercept. If we look at the points 1, 2, 3, 4, so its coordinate is going to be 4, 0, versus the y-coordinate 1, 2, 3, 4, 5, 6. So that's the y-intercept, and that's 0, 6. So that's the x and y coordinates. So here, let's find the x and y coordinate intercepts of this specific equation. So to find the x-intercept, I'm going to plug in y equals 0. Because an x-intercept, it's where you're crossing the x-axis, and that's where you're going to have a value for x. So negative 2x minus 0 minus 4 equals 0. So negative 2x minus 4 equals 0. Add 4 on both sides. Negative 2x equals 4, so x is equal to negative 2. So you can see my two numbers for my coordinates, so negative 2, 0, negative 2, 0, it's right there. Let's find the y-intercept. So that's where x is going to be equal to 0. So negative 2 times 0 minus y minus 4 equals 0. So minus y minus 4 equals 0. Add y on both sides. Negative 4 equals y. So here's negative 4, 0, so 0, negative 4. 0, negative 4, which is right here. So it's going to look like this. There's your graph. And lastly, Sharon is selling pies to make some extra money. She sells each apple pie for $3.75 and each peach for $4.25. Her goal is to make at least $183 in order to afford concert tickets. So write an equation that models the different amounts of pie she needs to meet her goal. Well, I know that each apple pie, so I'll just say that's 3.75x. So that's the number of apple pies, plus 4.25y for the number of peach pies, is going to equal 183. Well, it's actually greater than or equal, but let's say it's going to be equal to 183. So we need to graph the relation. Does it represent a function? Well, the x-intercept is going to be when y equals 0. So I have 3.75x equals 183. So if you divide by 3.75 on both sides, you'll see x is equal to 48.8. So that means she can't sell 0.8 of a pie, so it has to be 49. So our first coordinate is 49, 0. Oops, our other one is going to be, let's check out the y-intercept. So that's where x is equal to 0. So I'm going to have, let's see, plug in 0 for x. 4.25y is equal to 183. Divide by 4.25 on both sides. let's see, y is going to equal to, divided by 4.25, 43.058. So if she sells 43, it won't be quite enough. So she needs to actually sell 44 in order to make her money. So say y is equal to 44, because don't forget, if she only sells 43, that's not quite enough money. This is assuming she sells 0 apple, and this is all peaches. So here, this is 0, 44. So I need to change my numbers. I need to go from 0, well, let's make it be, that's 10, 20, 30, 40, 50. And then we got to go all the way over to 49. So let's say this is 10, 20, 30, 40, 50. Okay. Let's go ahead and plot. So my gray, my y-intercept, 0, 44, which is about right here. And my other one, 49, 0. 49, 0 is right here. So if I connect them, it's going to look like this. Oops. Again. There we go. Pretty close. That's what the graph would look like. So at any point, I could choose maybe right here. That looks like a nice point. So that's about 30 and 15. So 30 of my y, which is peaches. So do 30 times 4.25. Plus, and I said about 15 of my apples, so 3.75. Let's see if that gets us to our money. So it's got to be close because it's on the line. So 15 times 3.75 plus 30 times 4.25. Hey, check it out. That point, even though I'm sloppy drawing, that's $183.75. That would make it. So that point works. So this is the point 15, 30. That works. I could pick any point over here and it would work. Because technically, remember, this is greater than or equal to. So if I sold 40 and 40, so right here, 40 and 35, that definitely makes me more money than I need. If she sells 20 apple pies, that's 20 times 3.75. Plus 25 peach pies, that's 4.25. Will we meet our goal? So I just plugged in, because the way I wrote it, my x is my apple, my y is my peach. Will we meet the goal? So I need you to plug it in. Go ahead, pause the video, plug it in. So 20 times 3.75 plus 25 times 4.25. Oh no, 181 and 25. Nope, she can't go to the concert. Not enough. Not enough dough. Literally dough for her pie. Okay, here's your assignment. Have a great rest of your day.